Hello, this is Paul from Foresight Tech. That's talking about the Hyperbola. Wait a little. So we're going to 10.4 as a Hyperbola. And the first, we're going to choose standard equation for two type of hyperbolas. The first type we call the horizontal type. Okay, we're going to horizontal type of parabola. So let's look at this graph. If this is y, this is x, I put the center of the geometry to here. So this is the center of the parabola. So in this case is 0, 0. And I will put one vertex here, vertex. So if this we call the V1. So the symmetry, another point here, if I call the V2. If I give it the distance from the center to the vertex, okay, is this one. If this distance is A, so this distance is the same, also give A. And then we have this kind of graph. Okay, so I want to look at looks like a parabola, but it's not. Okay, this is one branch, so another branch is like here. It's a rough. Okay, this is very rough. Everyone, you can see. So this is the graph of a horizontal type of hyperbola. So I was going to put this V2. Now I can give a coordinate which is A0, right? So this V1 should be negative A0. Okay, so this A we call the, and these two we call the vertex. So vertices, we have two vertices. And we're going to the definition, we need the one more. Focus. Okay, so if this is a one foci, so one focus, if I call the F2, okay, and the symmetry is here is F1, F1. So I need to give the distance from the vertex to the focus. So give you a distance. If I use a parameter c to describe, so the same here is a parameter c. Okay, c is a positive number. All this now I can give the coordinate for f, which is so this one is I will give you. I will not give you this. Sorry. So I will give you the distance from. If I give you this c is too complicated for the I have to do this. It's not easy to give everyone. So I give it this distance. Can you see? Is c. Okay, means the center to the focus is c, the distance. So this is not a c, and this distance is c. Okay, and then I can put. Keep in mind the focus f to the center we call the c, and this time the coordinate of f is c0. The coordinate of this f is negative c0. We have almost done. Why we have this graph? The definition is this: any point on the graph, if I say this is q, and there's x, y, okay, any point on the parabola, the hyperbola, so we can find the two distance. One distance is this. I link f1 to q. So this is f1 to q. This is f2 to q, right? Okay, the definition is this. Q to f1, the distance, this time minus the distance q to f2 equals 2a, which is from this vertex to this vertex equals 2a. I want this is the definition. This is the definition. And then based on this, we can do calculation. You know this point is better. You know this point, you know this alpha, so you can find the distance. You also can find the distance for q to f2. So this is the equation. is as very similar as what we did for ellipse. So we can do calculation, along the calculation we find a standard equation. For this parabola, standard equation is this. So x squared and then over this is a squared and then minus y squared over b squared equals 1. If I change it to plus, this is a parabola, it's ellipse, right? But it is a minus. This we call the standard equation. This is a standard equation. And so everyone, from here to here, I did not give you the proof. I give you x squared in the blackboard. This is already x squared is open in blackboard. It's already open in blackboard. Everyone. So this is due next Monday. Okay. And this is the first step. Let me see what is B. It's very strange, right? So we have A, we have C. So why we have a B here? And the relationship between the ABC is this. I gave you the relationship between ABC. This time C is longer than A. In ellipse, A is the longest parameter, right? So this time C is the biggest parameter, which is this C squared equals A squared plus B squared. Okay, I want this the relationship. C is the biggest. So how to find the B? Of course, you know how to find the B, right? So find the B is this. B equals square root of C squared minus A squared. See, in this graph we have a C, we have A, then we can find a B and plug in. So this is the standard equation. This is what? This is the center in 0, 0. Can find this is center. This one is the center equals 0, 0. Okay. If the center is not 0, 0, we will extend. Okay. So we will extend this. Okay. We shift the center. You can do this. You can do shift the center to this H and the K. Right, we can shift whatever. Now I get another graph and we get another standard equation. Let me see, did I miss anything? Okay, so I want to look at it. We have axis, right? So these we have two axes. So this is the major axis. So this number we not call the major axis. This x-axis, and then we call the transverse transverse axis. Everyone, I'm not going to write transverse from this vertex to this vertex. So this axis we call the transverse. So how do you say? We say V1 to V2. So this 9 segment we call the transverse. You know, it's transverse from the left to the right axis. We call it axis. Of course, we have another axis is a y-axis, right? This is another you can call. This is also axis is talking about the symmetry, the symmetry axis. Okay, so you can say another or minor axis or whatever. And then we extend this to the center shift. Okay, everyone. So if the center is going to this time, the center going to H and the K, we're going to draw a graph again. So we're going to draw a graph. So very similar to this. But a lot of coordinate will change. We'll draw this. This is not the x-axis, okay? I will draw the center first. So this point this time is the center. Okay, so I put it here, the center, which is HK. Means what? It means this is the transverse axis, right? This time is not x, should be y equals k, right? This is y equals k. So this time this one is not a y, should be x equals h. So we identify a point in the center, and then the same. Okay, so I find A. This is the first. This is a vertex, and wait. Let's see. Okay, so we have another is here, so the same, okay, as the record. This is the first vertex is V1, this is the second vertex V2, and remember the definition, right? So this distance is dA, this distance is dA, so we can identify the coordinate. So this time the coordinate no longer A, right? So X is no longer A. I guess this point is from the center shift right. A, the original here is H plus A. So I want here should be H plus A for X. K, we did not change, right? Y always is K. And the same, so this V1 should be this. This point shift the left, so H minus A and K. Okay, we determined the vertex. Another is we're going to determine, okay, I'll draw the graph first. I draw the graph. No matter, here is the graph, so look at it. That is symmetry. Okay, so we're going to draw. So everyone, it should be symmetric. My drawing is not very good. And we're going to identify this is the focus. So this symmetric is another focus. The same I put here is F1, so here is F2. Okay, and remember, so here I missed it, so here I miss. And we have the definition for parameter C is the distance from the center to the focus. How do you say? So I have to do this time a little bit better. Okay, so everyone, you can see this distance we call the C. So the same. And so this distance we also call the C, right? That means C is the distance from the center to the focus, to any of the focus. So right now, so we can find F2. F2 is from the center shift right C, which means H plus C, right? H plus C for X, K, Y is still K. So F1 is the same, so we can do this shift left C, which is H minus C, and the Y is the same K. Everyone, we find most of the one, the center, the vertices, the foci, two foci. And then the definition, you know, is the same. Okay, the definition is this one. I will not going to if this is a Q. If this is a Q x y, and link link this point and link this point, what do we get? So this distance minus this equals 2a. Okay, the length of the transverse axis. So they are the same. I want to look at the Q to F1 minus Q to F2. The distance equals 2a. No difference with the left. That's the definition. And the same, we will find this you don't need to do. Okay, so it's just a shift. I will show you the formula, which means the X shift, right? So the X minus H and the square over A square minus Y minus K square over B square equals 1. I want this the standard equation. Of course, if you want to do, you either use shift, you learned from pre-calculus, or you from the definition from here to here, no matter what. Okay, so you can shift to get this equation, or you can use the definition to get this equation. This is whatever we call the standard equation. Standard equation. And this is a horizontal type. Keep in mind that this is a horizontal type. Okay, because and the hyperbola is open, the horizontal. The left branch open toward the left. This is open toward the right. This is a horizontal type. And the transverse axis is a horizontal axis, which is a y equals a k, right? And the same, the parameter is c square equals a square plus b square. Okay, and then how to find the b is from c square minus a square take square root. No difference. And this is the most important. This is special case, right? The center at 0, 0. See, when we put the h equals 0, k equals 0, and they will go back to the special case at here. Everyone, so this is the first type. And then I will going to draw the second type, which is the vertical. Okay, and also how to deal with the A, B, C in geometry. Later we are going to show you later. Okay, so we will have another, we call the asymptoton. Asymptoton can show you where is the exact relationship between A, B, C later. Horizontal, and then we're going to vertical. The second, let's see. Yeah, vertical. So the second is a vertical type. Okay. If we get the equation, then I will ask you to compare between these two. First, as I gave you the center. The center is at 0, 0. This is the easiest. Okay, so I will put the graph. Okay, so like this. I will going to draw a graph. Now I will move a little bit faster than before. Okay, I'll draw the graph first. I draw the graph first. Just roughly, okay, I roughly draw a graph. And everyone, this is axis, this is the y-axis. Okay, so this is the center, right? So I'm going to put this is the center. Now this is sorry, this the vertical is the same type. I have to change this, and I have to give it another. This is the horizontal type. I have to give you another paper to get a vertical. Sorry, we need to get a vertical type. Okay, but your vertical, so they are the same. The first I give you center at the 0, 0, the easy way, and I draw this is the x-axis, and this is the y-axis. Okay, so this time I have to put the vertex here. Okay, symmetry, and then I'll draw a parabola. This should be open up. So this should be open down. Everyone, can you see this time? Yes, this is open up and down, two branches. So we call the vertical. And then we're going to identify the properties. So this is the center, right? So we call this the center. Center is 0, 0. And this is, if we call it, this is V1. So this is the vertex. Okay, V1 is the vertex, the first vertex. So this is the second vertex, and the definition is the same. Okay, this is the first parameter, which is A. So this is A, means the distance from the center to the vertex. So we use the parameter A to describe. Then we will have V1 is this center point that goes up, right? So everyone, you know this should be x is still keep 0, y is goes to A. And this is a negative A, right? So x is 0, y is a negative A. It means it goes down A. One more is the focus. So here the focus. So here is the focus. So if we call the F1, so this is F2. And I will get this. The definition for another parameter is the distance between these two. We use C to describe. Okay, the center to the focus is C. Now is the same. Is the same definition. So this distance we call the C. Now what we can find, so this is C, right? So x is 0, y is C. So this is negative C because it goes down to the bottom, which is x0 negative C. Okay, good, all the parameter. And then the definition is still the same. I will go to the road. Any points on the graph, and so this time look at it. The distance. The distance we need to change it a little bit. Look at it. In this one, the distance should be q to f2 minus q to f1 equals 2a. If the point on this branch should be q to f1 minus q to f2 equals 2a, right? Always the same. The distance equals 2a, which is the length of the transverse axis. So we see this is the transverse axis, right? So we say this is the transverse axis. Okay, this is the axis. Of course, you can say this is another symmetry axis, or sorry, see. Okay, I think now you can see. And they use the definition, the distance equals 2a, and then we're going to find the standard equation. I just draw the standard equation here. So this time y go first, so y square over a square minus x square over b square equals 1. So here we got the standard equation. This is the standard equation. Okay, of course we use the same definition. Okay, any points, you can say any points that go to, if this is q, qf1 minus qf2 equals 2a, and to do calculation you get this one. Relationship, how to find the b. B is linked to AC. Okay, I will put it here again. Relationship between A, B, C is still the same. C is the biggest, a square plus b square. Okay, this is the relationship between A, B, and C. Of course, if you know any two of them, you can find another. So this is the first type of vertical. Okay, you see this? And the second, let me look at the difference. Can you see? We just see the horizontal type. I want put it here. You can see what's the difference. What the difference between them? If it's a horizontal, x go first. So you can you see this? If it's a horizontal type, x go first. X minus y. And if it's a vertical, it's y minus x. Y go first. Which parameter go first is which type. Okay. Why is this? And because why this is a y go first? I want because what? Because y, and we look at the range for y. Okay, you see, I show you a little bit. I show you a little bit of y. So now you can see the difference. Okay, I will show you why this is true. Not only the proof. Okay, so it's very easy. So can you see this? If I say x square over a square b square equals 1, so this one is horizontal, right? We already know y is horizontal. When this is x goes first, you can say x minus y. Always a is go with the first ab. Okay, and then we going to do this. Can we solve x square over a square equals 1 plus y square over b square, right? And this one should be what? This is a positive number, okay, or at least a non-negative number. So this is over 1 or greater than or bigger than 1. Everyone you can get x square over a square greater than or equal to 1. Means x square greater than a square. Everyone can use over this. What do you find? You will find that the absolute value of x greater than a. And this means what? Means either x greater than a or x less than negative a. Can we going to see? Is this true? Is this true? X, the middle we cannot take any value. And all the points on the graph for x is either on the right branch a, x is greater than or equal to a, right? Because at the right size. And the left branch for any points x coordinate should be x less than a. Okay. Have you get this? So you can do easy. Okay, if x goes first, now if x goes first, x should have this range. This means it's horizontal. The same way. So if we're going to this, you also can solve for y, right? Y should be either greater than a. This is the upper branch, or less than negative a is the last is the this branch, the second below branch. Have you get this? There's a little bit. So now we go back into the vertical, and what are we going to do now? You know, is going to shift, right? So shift. So going to shift. So now the center no longer. This is the general. Okay, center not always 0, 0. The general is HK. Okay, now is the same. I will going to draw the center first. Okay, but this time is no longer XY. And if I put the center at here, so this center, so what do we say? the sender is HK, right? So, and this is one axis, so y equals k. So this no longer y, should be x equals h. And the same is open up and down. So I will get this is v1. Okay, and this say this is v1. So this is v2. So I draw the graph first. Okay, whatever. So did the graph open up the first branch, second branch open down. And you see this parabola very symmetric. So we look at the definition is the same. Now here is a. The distance from the center to the vertex is a. So we can identify what is v1. So v1 is what? v1 is this point up a, h, no change. K up a, k plus a. What is v2? v2 is this point go down a, h, no change. K minus a. Okay, so you have these 3 points. And then another 2 is the focus. So one focus, two focus, two foci. Okay, so I've called this is f1, this is f2, the same. And the definition is this. This is C. Okay, the center to the foci, the one of the focus is C. So I will get this. So these distances they are C. Everyone, you can determine what is f1 now. So this is shift the up. So h no change, x no change, y goes up C. So k plus C, right? So this point should be h, and this go down C, k minus C. Everyone, have you get it? I think this is all. Okay, so this is the transverse axis. This is the same as the transverse axis. And another this symmetry, another axis. Okay, the mono axis. What is the equation? The equation. So everyone know this is just a shift for the x and the y, right? So y minus k always. Keep in mind this is always for y. This is always for x. So we will have y minus k square over always a, okay, minus x minus h square over b square equals 1. Okay, I get it. It's the standard equation, general. The standard equation. And the relationship between A, B, C is all the same. C square, A square plus B square. However, you get it. It's the relationship. Everyone. So this is the general. This is the most important, right? Okay, so we compare to the first. I showed you. Okay. So this is 2 general. So this is vertical, the general vertical standard equation. This is the general for horizontal type. So everyone, have you get it? This is the definition. I will upload this video for you first. Okay, it's going to reach, and then I will going to give you example. Okay, another 2 example a little bit later. Yeah, thank you. So I'll go back a little bit later.